Star Wars is one of the greatest franchises ever made, but it doesn't always follow the laws of physics. Cough, cough, The Last Jedi. But today, we're going to be looking at one of my favorite series from Star Wars, Star Wars The Clone Wars. I'll be analyzing two scenes from Star Wars The Clone Wars that are analyzing a same principle of physics. For some context, the characters are underwater trying to fight a civil war on the planet of Mon Cala. The Republic is aiding the Mon Calamari, while the Separatists are aiding the Quarren people. Also, I'll be assuming that Mon Cala will have Earth-like conditions, as I wasn't able to find what type of gravity this planet experiences. It has a diameter similar to that of Earth, as well as the Sun, but the only major difference between Earth and this planet is that this planet's entire surface is composed of water. I'll be assuming that this planet is composed of fresh water, which means it has a density of 1,000 kilograms per meters cubed, and I also assume that this planet has the same gravity as Earth, which is 9.81 meters per second squared, because I know that this planet has an atmosphere composed of oxygen. So let's get into the first video thing. So the principle that Anakin kind of broke was hydrostatic pressure, because let's assume that he was in the Twilight Zone, because we could see that light was fluctuating while he was trying to find his helmet, and reinforcements took a while to get to him, even with speeders. So let's say that they're about 300 meters underwater. Well, if we think about it, if he's 300 meters underwater, he has all of the weight of the water above him pushing on him. And we know that pressure is equal to force over area. So we know that hydrostatic pressure is a pressure that's being applied to him because of the water. And then we know that there is atmospheric pressure above it pushing on down. So it doesn't really make sense that he loses his helmet 300 meters underwater and he's able to continue fighting the way he is. So I'm going to do the math in 1 second. Alright, so I just did the math, and basically, as I said before, hydrostatic pressure is going to be P equals the density of the fluid times gravity times the height of the water above the object. In this case, it will be Anakin. So I know that the density of the fluid, which is going to be fresh water, as I assumed, is going to be 1,000 kilograms per meters cubed. Gravity, which again I'm also assuming is Earth-like, so it's going to be 9.81 meters per second squared. And I assumed that the height was 300 meters. The amount of water was 300 meters above him. So that gave us 2,943,000 pascals. But that is just our gauge pressure. If we want to find the absolute pressure, because they do have an atmosphere, so we can include the pressure, assuming it's the same as ours, to be 1.01 times 10 to the fifth. And then we basically get that what's it called? We get 3,053,000 pascals as the pressure. Now there is a lot of stuff that's kind of weird with what's happening, because if you look at the scene properly, Anakin is using his lightsaber like he normally would on land, and we know that's not possible because on the air's density is 1 kg per meters cubed. Water is way more dense than that. It should be much harder for him to move his sword. He shouldn't be able to move his sword as much because it's denser. And two, pressure was pushing on him, and he lost his helmet, which means that his entire face was experiencing the pressure above him. So I don't know how he's able to maintain fighting when he has so much pressure on him. He probably should have died there, because he probably would have not been able to use his lightsaber as effectively, or the water, due to the immense amount of pressure on him, should have pushed up his nostrils and his ears, and it should have drowned him. So, yeah. So let's look at the second clip.
Well, Prince, how do you feel about fighting again?
Master Jedi, we're too vulnerable here. We must reach the sea floor.
Grab on to the debris. Let it carry you to the bottom.
I think I'm getting seasick.
Not sure that's the best strategy.
I'm sure. Captain Akbar's words are my own. It will give us the best chances of surviving if we split up.
As you wish. Ahsoka, you and the Prince go with Kit and take the clones. I'll take the Senators and Captain Akbar. Lay low. Our only hope is that Master Yoda can send help in time.
No. Princely Cha is our only hope.
Dude, Anakin knows about the buoyant force, but he still doesn't know anything about hydrostatic pressure.
Liar!
So let's start off with the physics that actually makes sense, which is what they did to get to the seafloor, which is they basically, when the frigate blew up, metal is way denser than water. It's much more than 1,000 kilograms per meters cubed. That means that the parts of the ship would sink. So if they grab onto it, that would cause them to also go down, because the buoyant force is going to be the upward force. The water is pushing the object up, but gravity is going to be pushing it down. Since these objects are much more denser, the gravitational force, or gravity force, is way stronger than buoyant force, causing a net acceleration downward. So that's how they got to the bottom of the seafloor. But let's think about this. Think about this for a moment. The deeper and deeper they get, there's a lot more pressure that's being built up on top of them. So let's think about this. On our planet, the average location of the seafloor is 2.3 miles, which is about 3,701.49 meters. Because yes, and I basically use this to calculate the pressure on Anakin, because all the other characters, they're not humans, if I remember correctly. But Anakin is technically a human. He should still be experienced. What we're experiencing should be the same to him. So we can calculate the gauge pressure simply by doing the same thing we did before, which is density of the fluid, which is water, 1,000 kg per meter cubed, gravity, 10 or 9.81 meters per second squared, and then the height, which I just converted to meters, 3,701, and you get this enormous pressure. Remember, this is all being pushed on you while you're at the bottom of the ocean. Today, only, if I remember correctly, submarines can go this deep. It's really difficult to survive under these circumstances. You would get squished because the water would crush you. And let's not remember that there's also the hydrostatic pressure we calculated was the gauge pressure. There's still some atmospheric pressure, which we're assuming is going to be the same as our Earth's, which is 1.01 times 10 to the fifth. And it leaves this huge 36,412,616.9 pascals of pressure being pushed upon Anakin Skywalker. He should be dead. And basically, if you were to recreate the scene, then this is a good depiction of what he should look like when he should be at the bottom. He should be dead. There should not be a Darth Vader roaming the galaxies. I don't understand how he's alive. Again, his gear is basically simple scuba gear. It's not specialized. It's not using any sort of metal from the appearance. So yeah, so that's basically it. When I was editing this, I forgot that you could also see some of the sunlight at the bottom of the seafloor, which shouldn't be possible because most of the sunlight should be absorbed within the first 200 to 400 meters of water. So it should be basically pure darkness down there, which it technically wasn't, which I don't think physically makes sense also. All right, bye.